Good morning, everybody. Myself, Acharya Vishvendra, and today I'll discuss a worksheet on indicator diagrams. So let's begin with the first question. A gas is undergoing a certain process 1 to 2, and the pressure versus volume curve is shown in the graph over here. So the first thing is shape of the graph is, so it's the shape is like rectangular hyperbola with the standard equation that v is equals to constant. So the shape here is of rectangular hyperbola. And if the shape is rectangular hyperbola, that means temperature has to be constant, because PV is equals to nRT. So for a constant number of moles of the gas, PV is constant only when temperature of the gas is constant. So here the assumption is that temperature is constant. So if we draw the PT graph of this, so temperature is constant, so it will be a straight line perpendicular to the temperature axis. Now point here is we have to observe that pressure decreases on moving from 1 to 2. So 1 will be above and 2 will be down like this. So that will be the pressure temperature curve for this particular situation. Next is VT graph. So since pressure is inversely related to the volume, so volume will increase, temperature is constant, it's given. So the graph will be like this. Then we have PT graph. So it's just like as we have done in degree centigrade also. Here scale is in Kelvin and here scale is in degree centigrade, but it doesn't matter. Shape will remain the same. Only coordinates may get shifted. As in degree centigrade the numerical value is less, so this value will get shifted over there. So this is how we can draw the graph. In the next question is another PV diagram. There are three states given by 1, 2 and 3, and it's being given that 2 to 3 process is an isothermal process. So we need to find T2. So if we look for state 1 and state 2, applying the general law for a constant mass of the gas, so we can say that P naught V naught by T naught will be P naught, volume here is 2 V naught and temperature is T2. So from here we can calculate that T2 is equals to twice of T naught. Then another question is find P. So 2-3 process is isothermal. So product of pressure and volume on these 2 points 2 and 3 will be constant. So from there we can say that P naught multiplied by 2 V naught is equals to P into thrice of V naught. After solving we get P is equals to 2 by 3 P naught. So that is how we can calculate the pressure at this point 3. Next is work done by the gas during 1 to 2. So as it is evident from the graph, it's an isobaric process. And for isobaric process, the work done is P naught into delta V. Delta V is the change in volume. So here it will be 2 V naught minus V naught. So work done will be P naught into V naught. Next is if gas is monoatomic, find change in internal energy during 1 to 2. So change in internal energy is given by NCV delta T. So CV here will be 3R by 2 into delta T. So from here it comes out to be 3 by 2 NR delta T, and NR delta T can be written as P2 V2 minus P1 V1. After substituting the values we get 3 by 2 P naught V naught. Then is find heat supplied to the gas during 1 to 2. So applying first law of thermodynamics, so we can say that delta Q is delta U plus delta W. So delta Q U here is 3 by 2 P naught V naught, and work done we have calculated here as P naught V naught, so that will be 5 by 2 P naught V naught. Then another question is find work done by the gas during 2 to 3. So since 2-3 process is isothermal, it's given in the question. So in isothermal process work done is nRT log V2 by V1. So after substituting the values we have twice P naught V naught log 3 by 2 to the natural base E. Then is another question, change in internal energy of the gas during the process 2 to 3. So since process 2 to 3 is isothermal, so we have delta T as 0. And change in internal energy is given by NCV delta T. So delta T is 0, that means delta U will also be 0. Then is find heat supplied to the gas during 2 to 3. So using the equation delta Q is delta U plus delta W. Delta U is 0 over here, delta W will be written like this. So delta Q will be twice P naught V naught log 3 by 2 to the base E. Then is next question, find work done by the gas during 1 to 3. So during 1 to 3 work done will be like sum of work done from 1 to 2 plus 2 to 3. So we have this expression for the work done during 1 to 3. Next is find heat supplied to the gas during 1 to 3. Using the same expression we can say that delta Q 1 to 3 will be delta Q from 1 to 2 plus delta Q from 2 to 3. Substituting the values we have this expression as the heat supplied to the gas during the process 1 to 3. So in this way you have seen that we have discussed a number of questions, like 15 questions over here, using different concepts of work done, internal energy, heat supplied, pressure, volume and temperature calculations from the indicator diagrams. So these videos are just an optimization tool for you, in which you can cross check your verification and can cross check that whether you are able to solve questions in different varieties, in different permutations and combinations as and when asked. In case of any doubt, you can ask in the comment section. Thank you and have a nice day.